Today's lesson is 1.2, Powers and Exponents. This is on page 10. Please follow along with a notebook and open your textbook to page 10. Powers and exponents. If we look at an example of a power or exponents, this is 5 to the third power, and it's equal to 5 times 5 times 5. In another way to think of it, it's 5 times itself. And how many times is it times itself? It's times itself 3 times. So it's 5 times 5 times 5. And 5 times 5 is 25. And 25 times 5 is 125. Now, let's look at the parts. And one of the parts that you guys need to know is that the bottom part is called, the 5 in this equation is called the base. I know that looks kind of goofy, but the number 5 in this equation is the base, and the 3 is called the exponent. And I'm just going to point from here, is the exponent. So this is 5 to the third power. There are a couple of exponents that you need to know. There are special ones, and I will give you an example of one of them. 9 to the second power. We can also say 9 to the second power or 9 squared. So we use 5 squared or 5 to the second power, and we use squared when we're thinking of things like area, the area of a room, the number of square feet of carpet needed. If you're trying to figure out the amount of paint that you need to paint a room, you need to figure out the square feet of the walls. Okay. The other special one that we have is when you have a number to the third power. And any number to the third power we can call cubed. Where we use cubed in real life is when we're talking about volume. If you want to find the amount of air in a room, you would use a cubic foot or a cubic yard or cubic inches if you're looking at something on a smaller scale. So just to summarize, the bottom of an exponent is called the base. The top part is called the exponent. Okay. Now let's look at a problem that you'll see on your homework tonight. And this is, the directions for this would be, write the product using exponents. So this is 7 times 7 times 7. Or another way to think of it is 7 to the, and which power would this be? Well, because it's times itself 3 times, it would be 7 to the third power. Let's look at another problem that uses variables. And in this problem, we can see that this is x times x times x times x times x. And that's going to be equal to x. And how many times are we timesing it by itself? 1, 2, 3, x to the fourth power. And that's how we write the product using an exponent. On this next example, we're looking at evaluate the expression for x to the fourth power when x is equal to 0.5 or a half. So what we need to first do is think to ourselves that x to the fourth would mean x times x times x times x. And then we need to put in this half. So we can identify that this is the first step, is taking this x to the fourth power and realizing that it is the same as x times x times x times x. The second step is actually putting this in, and from this point you could use a calculator and just say 0.5 times 0.5 times 0.5 times 0.5, and we could figure out that that is equal to 0.0625. Most of this exponent stuff, it's very handy to use your calculator. I do not have a problem with you using your calculator. To use your calculator, how you would punch this one in is you would put 0.5, and then you would either hit your y to the x power button or x to the y power button. Most of you guys are going to have a calculator that has a button like this, kind of like upside down, like kind of like an arrow pointing up. And so on your calculator, you would point in 0.5, and then this button, I usually call it the to the button, or 0.5 to the, and then here you would enter 4 to the fourth power. And then you could hit equals, and it would give you the answer. The next problem that I'm going to do is on the bottom of page 11. It's a story problem, and it's about an ice sculpture. An artist uses a cube-shaped block of ice to make an ice sculpture for a competition. Find the volume of the block of ice. And they give us an image that has 20 on each side of the cube. And we're going to use the formula that is volume is equal to side length to the third power. Well, if we look at the image, we know that our side length is 20. What is it, 20 centimeters? 20 inches. And so to find the volume, we just plug in 20 for S. So volume is going to be equal to a side length to the third power. If we want to stretch this out, it would be 20 times 20 times 20 equals, or if you could use the to the button, you would have 20 to the third power is equal to 8,000. Let's try one more of these using the same formula. Let's say that our side length is, let's say that our side length is 10. So we would simply do 10 to the third power. And 10 to the third power is kind of an easy one to figure out, because 10 times 10 is 100, and 100 times 10 is 1,000. All right, and this concludes this lesson. And your homework for tonight will be page 12, problems numbers 13 through 28, 30 through 33, and 39 through 47. If you have any questions while doing your homework, please raise your hand and I'll come over and help you.